In the previous class, we have discussed some sums, some problems in exercise 5.1 based on the continuity of f at a given point. Okay, my dear children, do the remaining sums. Question number 8, question number 9, question number 10, question number 11, question number 12, question number 13, question number 14, question number 15, and question number 16. You try these questions as I have explained some questions. Just observe the solutions in the previous questions and try these questions. Will you do these questions as homework? If you have any doubt, ask your doubts and get your doubts clarified. But do all these sums as homework. Okay, my dear children. Now come to the question number 17. See question number 17. Find the relationship between A and B so that the function f defined by f of x is equal to ax plus 1 if x is less than or equal to 3 and f of x is equal to bx plus 3 if x is greater than 3 is continuous at x is equal to 3. Understood the question, my dear children? First read the question completely and clearly and understand the question first. Okay, my dear children, here the given function is continuous at x is equal to 3. Then we have to find the relationship between A and B. Is it clear the question, my dear children? Right. Now I am giving the pictorial representation of the given function on the number line. See here on the number line 0, 1, 2, 3, 4. On this number line at x is equal to 3 I have drawn a line. X less than 3 means left side of this line. X greater than 3 means right side of this line. So if x is less than or equal to 3, how the function f is defined? F of x is equal to ax plus 1. So in this part, left side of x is equal to 3, I wrote f of x is equal to ax plus 1. And if x greater than 3 means right side of this line x is equal to 3, I wrote f of x is equal to bx plus 3. Is it clear this picture, my dear children? Right. Now we have to find left hand limit and right hand limit of f at x is equal to 3. As we did in the previous questions, we follow the same procedure. Okay, my dear children? Right. Now we are going to find left hand limit of f at x is equal to 3 and right hand limit of f at x is equal to 3. Is it clear, my dear children? Right. So first we are finding left hand limit of f at x is equal to 3. We write symbolically as x tends to 3 minus limit f of x is equal to, as x tends to 3 limit ax plus 1. In the place of f of x, I have taken ax plus 1 because as x tends to 3 minus means x is less than 3. X values are less than 3. Then f is defined as f of x is equal to ax plus 1. That is why I wrote here ax plus 1 instead of f of x. Understood this step, my dear children? Is it clear? Right. Now we are going to find the limit of this function by the method of substitution. So it means we have to substitute x is equal to 3 in this expression. See here we are substituting a into x means 3. A into 3 plus 1. Understood this step, my dear children? Right. That is equal to a into 3. What will you get here? 3a plus 1. This is the left hand limit of f at x is equal to 3. Similarly, we find right hand limit of f at x is equal to 3. Symbolically, we write like this: as x tends to 3 plus limit of x is equal to, as x tends to 3, limit f of x means bx plus 3, because as x tends to 3 plus means x is greater than 3, x values are greater than 3. Then f is defined as f of x is equal to bx plus 3. That is why here I have taken f of x is equal to bx plus 3. Is it clear this step, my dear children? Right. Now we are going to find the limit of this function by the method of substitution. Means in the place of x we substitute 3. So b into 3 plus 3. Okay, my dear children. Understood this step, my dear children? Right. Now by simplifying this first term we get 3b plus the second term 3 as it is. Is it clear this step, my dear children? Right. This is the right hand limit of f at x is equal to 3. Now f of 3, we are going to find f of 3, that is equal to b into 3 plus 3. Here I have taken f of x is equal to bx plus 3 because x is greater than or equal to 3. If x value greater than 3 or if x is equal to 3, f of x is defined as bx plus 3. So in this function we substitute x is equal to 3. Then we get here 3b plus 3. So this is left hand limit and this is right hand limit, and this is the function value at x is equal to 3. Now these three values are equal. We should equate these three values because it is given that f is continuous at x is equal to 3. In the question itself it is clearly given. Okay, my dear children, that is why I am writing this step as x tends to 3 minus limit f of x is equal to, as x tends to 3 plus limit f of x is equal to f of 3. Understood this step, my dear children? Right. So we have taken this part. Okay, my dear children, this implies as x tends to 3 minus f of x, what is the limit, left hand limit? 3a plus 1 is equal to, this is right hand limit. What is the right hand limit? 3b plus 3 is equal to, what is f of 3? 3b plus 3. So we substituted these three values in the equation. Understood this step, my dear children? Is it clear? Right. Now if you observe this equation, there are three parts. This is the first part, 3a plus 1 is first part, 3b plus 3 is the second part, and 3b plus 3 is the third part. Three parts are there in that equation. Now by taking the first part and the second part, we get an equation like this: 3a plus 1 is equal to 3b plus 3. I have taken here first part and second part. I wrote this equation. Is it clear, my dear children? Right. Now we are rearranging the terms. 3a, we are bringing 3b to LHS. It becomes minus 3b is equal to, we are sending plus 1 to RHS. It becomes minus 1. 3 minus 1. Understood this step, my dear children? Right. This implies by taking out the common factor 3, we get 3 of a minus b is equal to 3 minus 1. What will you get here? 2 in RHS. Understood this step, my dear children? Right. Now by sending this 3 to RHS, it becomes by 3. So this implies a minus b is equal to, just we are sending this 3 to RHS. So 2 by 3. This is the required relationship between a and b. Is it clear, my dear children? Right. Now come to the question number 18. For what value of lambda is the function defined by f of x is equal to lambda of x square minus 2x if x is less than or equal to 0, f of x is equal to 4x plus 1 if x is greater than 0, continuous at x is equal to 0. Understood this question, my dear children? Here also we have to find the value of lambda. If f is continuous at x is equal to 0, what are the values of lambda? And the second part, what about continuity at x is equal to 1? This is the second part of the question. In the first part of the question, we have to find the values of lambda at which the function is continuous at x is equal to 0. And the second part is we have to check the continuity of f at x is equal to 1. Understood the question, my dear children? Right. Now I am giving here pictorial representation of the function f on the number line. Here x is equal to 0, at x is equal to 0. Left side means less than 0. Right side of this line is greater than 0. So f of x is defined as lambda of x square minus 2x if x is less than 0. So left side I wrote here. If x is greater than 0, how the function f is defined? F of x is equal to 4x plus 1. So right side of the 0, I wrote here f of x is equal to 4x plus 1. So in this case, we have to find left hand limit and right hand limit of f at x is equal to 0, and we check the continuity and find the lambda values. Okay, my dear children? Understood the question, my dear children? Right. So now we are finding left hand limit of f at x is equal to 0 and right hand limit of f at x is equal to 0. Okay, my dear children? See here, symbolically we write as x tends to 0 minus limit f of x. To denote left hand limit of f at x is equal to 0, symbolically we write like this. That is equal to as x tends to 0 limit lambda of x square minus 2x, because as x tends to 0 minus means x is less than 0. X values are less than 0. In that case, f of x is defined as lambda of x square minus 2x. That is why here I have taken f of x as lambda of x square minus 2x. Understood this step, my dear children? Right. Now we have to find the limit of this function at x is equal to 0 by the method of substitution. So that is equal to lambda of 0 square x is equal to 0. Put x is equal to 0. So 0 square minus 2 into 0. Understood this step, my dear children? Right. So lambda into, by simplifying these two terms, we get to 0 only. Lambda into 0, any number into 0, we get here 0. Understood this step, my dear children? Right. So left hand limit of f at x is equal to 0 is 0. Similarly, we find right hand limit of f at x is equal to 0. We denote it symbolically as x tends to 0 plus limit of x. That is equal to as x tends to 0 limit 4x plus 1, because as x tends to 0 plus means x is greater than 0. X values are more than 0. Then f is defined as f of x is equal to 4x plus 1. That is why here f of x is taken as 4x plus 1. Understood this step, my dear children? Right. Now we are going to find the limit of this function at x is equal to 0 by the method of substitution. Means just we substitute x is equal to 0. We put x is equal to 0. That is equal to 4 into 0, 4 into 0 plus 1. Understood this step, my dear children? Right. By simplifying these two terms, what will you get here? 1. What is RHL of f at x is equal to 0? 1. Here left hand limit of f at x is equal to 0 is 0. Right hand limit of f at x is equal to 0 is 1. Both are not equal. Therefore, f is not continuous at x is equal to 0. Is it clear this step, my dear children? Right. Therefore, for no value of lambda, here it is not possible to find the value of lambda. Okay, my dear children? Therefore, for no value of lambda, f is continuous at x is equal to 0. We are not able to find the value of lambda, so that f is continuous at x is equal to 0. Okay, my dear children? Right. This is the first part of the question. Now we go to second part of the question. Okay, my dear children. Right. Now come to the second part of the question. What is the second part of the question? Whether it is a continuous function or not at x is equal to 1. So we are verifying the continuity of f at x is equal to 1. So we are finding here limit of the function at x is equal to 1. As x tends to 1, limit f of x, that is equal to, as x tends to 1, limit 4x plus 1. Instead of f of x, I have taken 4x plus 1, because as x tends to 1 means x value is greater than 0. In that case, f of x is defined as f of x is equal to 4x plus 1. That is why I wrote 4x plus 1 in the place of f of x. Understood this step, my dear children? Right. Now we are going to find the limit of this function at x is equal to 1 by the method of substitution. Okay, my dear children? Right. That is equal to, we have to put x is equal to 1. We have to substitute x is equal to 1 in this function. So 4 into 1 plus 1. I substituted x is equal to 1 in this expression. Then we get 4 into 1 plus 1. Understood this step, my dear children? Right. That is equal to 4 into 1. What will you get here? 4 plus second term 1 as it is. I wrote here. Understood this step, my dear children? Right. 4 plus 1. What will you get here? 5. This is the limit of the function f at x is equal to 1. Now we find the function value at x is equal to 1. So 4 into 1 plus 1, because f of x is equal to 4x plus 1 if x is greater than 0. Whatever the value it is, if x is greater than 0, f of x is defined 4x plus 1. So at x is equal to 1 also, we have to take f of x is equal to 4x plus 1, and we substituted x is equal to 1 in this function. So 4 into 1 plus 1. Understood this step, my dear children? Right. Then we get here 4 plus 1. By simplifying these two numbers, what will you get here? 5. So here limit of the function f at x is equal to 1 is equal to 5, and the function value at x is equal to 1 is also 5. Both are same, both values are equal. Therefore, as x tends to 1, limit f of x is equal to f of 1. Both are equal. Therefore, we can say that f is continuous at x is equal to 1. Is it clear, my dear children? Right. Now come to the question number 19. Show that the function defined by g of x is equal to x minus step x is discontinuous at all integral points. Understood this question, my dear children? Here g of x is defined as x minus step x. This is a given function. We have to show that it is discontinuous at all integral points. Integral points means integers. At all integers, we have to show that this function is discontinuous. Here step x denotes the greatest integer less than or equal to x. Okay, my dear children? Here step x is the greatest integer function, and its value is greatest integer less than or equal to x. Prerequisite means previous knowledge. To solve this question, you have to know this knowledge. If n belongs to z, if n is an integer, as x tends to n minus, limit step x is equal to n minus 1. As x tends to n plus, limit step x is equal to n. This is left hand limit and this is right hand limit. If n is an integer, then its left hand limit value is n minus 1 and its right hand limit value is n. Understood this point, my dear children? Right. Now we are finding left hand limit of g at x is equal to n and right hand limit of g at x is equal to n. we have considered n is an integer. At all integer points or at all integers, we are finding left hand limit and right hand limit. So left hand limit of g at x is equal to n is denoted by symbolically as extends to n minus limit g of x. That is equal to as extends to n limit x minus step x. G of x is defined as x minus step x. That is equal to substitution method, by the method of substitution, n minus step x limit is n minus 1, because as extends to n minus limit step x is equal to n minus 1. Previously we wrote that point. Understood this step, my dear children? Right. Now by simplifying these terms we get n minus of minus plus 1. Understood this step, my dear children? Right. Now n minus n gets cancelled. Finally we get here 1. This is the left hand limit of g at x is equal to n. Similarly we find right hand limit of g at x is equal to n. Symbolically we denote it as extends to n plus limit g of x is equal to as extends to n limit x minus step x. That is equal to that substitution n minus, but its right hand limit is n only, because as extends to n plus limit step x is equal to n. Understood this step, my dear children? Right. N minus 1, n minus n gets cancelled. You get here 0. So this is the right hand limit of g at x is equal to n. Here by observing these two limits, they are not equal. Therefore as extends to n minus limit g of x is not equal to as extends to n plus limit g of x. Both limits are not equal. Hence g is discontinuous at all integral points. At all integers the function g of x is discontinuous. Understood, my dear children? Right.